All right, this is the video on section 9.3. And basically what this video is about is going back and forth between rectangular coordinate plane to polar coordinate plane. It's almost like that if you had a rectangular graph and you superimposed a polar graph on top of it. So if the purple is your rectangular, and then this is going to be your polar, and of course you're going to have your lines through it, and it's figuring out the points on one, how it would be comparable to the points on another. So the very first thing we're going to do is we're going to convert from a polar point, so an r theta, to an x y. And the big things about this would probably be x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. Those are two things you want to remember all the way through this. So let's say I have the point P, which is 5 pi over 3. So if I go over here and I go, oh, I want to graph this, I guess I didn't do enough circles. I need 2 more. So pi over 3 is right there. 1, 2, 3, 4, 5 would be that point. And I want to know, if I'm talking about a rectangular coordinate plane, what is the ordered pair for that point? What is the x and y? So I'm going to change this polar point to a rectangular point by using this right here. The x is equal to 5, that's the r, remember, this is your theta, times the cosine of pi over 3. So I've got 5 times the cosine of pi over 3, of course, is 1/2. So my x value is 5 over 2, or 2.5. So that's my x coordinate. Then I need to do the y. Y is equal to 5 times the sine of pi over 3. So I have 5 times the square root of 3 over 2, because that's the sine at pi over 3, which is going to give me 5 on the square root of 3 over 2, or the decimal value of that is 4.33. You can actually leave it. You can leave it here and here if you want. But I want to show you how it works. So this is the coordinate plane, the Cartesian coordinate plane, x and y. So if you look at this, this would be over about 2.5 and up about 4.33. Let's do another one. Okay, now this was done in radians. Sometimes they give it to you in degrees, and you'll have to adjust your calculator. Now, none of this we would have used our calculator for, except for maybe this or this. And that's okay no matter whether it's in radians or degrees. It's going to give you the same answer. Let's do another one here. All right, remember we're still going from polar to rectangular. Let's say my Q value is negative 17 or negative 1370. Now that's going to be a little different because I don't know 70 degrees on my unit circle. So I'm going to have to use my calculator for that. But your calculator probably right now is in radians based on what you did last as far as graphing these. So you want to now real quickly, because that's in degrees, you want to switch it to degrees, but you're not going to stay in degrees long on this section. So x is equal to negative 13, the r, times the cosine of 70. Now if you're trying to find the cosine of 70 degrees, you have to have it in degrees, and that's going to give you a value of negative 4.45. The y would be negative 13 times the sine of 70 degrees. So when you do that out on the calculator, you're going to get 12.22. So negative 1370 on a polar graph is the same as negative 4.45, 12.22 on a rectangular graph. All right, now why don't you try a couple, and you can pause the video and come back to it and make sure that you got them right. Okay, well now we're still going from polar to rectangular. We haven't done the opposite way yet. All right, so try these. Negative 2 and negative 5 pi over 6. And let's do 3 and 270. Now, you would have to have it in degrees to do that one. Since it's in degrees, you might want to do that one first. But go ahead and do it, pause the video, and come back. All right, x is equal to 3 times the cosine of 270 degrees, which if you've done it right on your calculator, or that one, you wouldn't even need your calculator because you know 270. So 3 times 0 is equal to 0. Y is equal to 3 times the sine of 270, and you know that to be negative 1. So y is equal to negative 3. Therefore, your point is negative 3, 0. That is comparable to your 2, negative, or I'm sorry, it is comparable to your 3, 270. All right, over here, I've got x is equal to negative 2 times the cosine at negative 5 pi over 6. So I have negative 2 times the negative square root of 3 over 2. That's going to give me a value of a square root of 3. You can just leave it as a square root of 3, or you can give me a decimal value, either way. And then, of course, your y is negative 2 times the sine of negative 5 pi over 6, which is going to give me negative 2 times negative 1/2, or 1. So this is going to give me the square root of 3, 1 as my ordered pair. All right, let's do the other way where you go from, we're going to just reverse this, from rectangular to polar. So we're going to go from x, y to our theta, rectangular to polar. So the big thing there, and I'm going to go ahead and add this to our list, is that r squared, or actually r, we'll do it this way first, is equal to x squared plus y squared, or r squared is equal to x squared plus y squared, and theta is equal to the arctan of y over x if x is greater than 0 or positive, and the arctan of y over x plus pi if x is less than 0. So if x is less than 0, you're going to add pi to your value. Now, you need to be back into radians to do these, so go ahead and convert back on your calculator. Let's start with an example like this, negative 8, negative 12. Okay, here, to get my r, I'm going to take the square root of this squared, 64, plus this squared, which is 144. So I have the square root of 208, which is 14.42. Okay, that's going to be my r, so 14.42. Now I'm going to find my theta. Now, make sure your calculator's in radians. I cannot emphasize that enough. So now to find my theta, I'm going to do the arctan of my y, negative 12 divided by negative 8. Notice that my x is negative, so I have to add pi to that. So when I get the answer there, I'm going to get 4.12. So my answer is 14.42 and 4.12. Now that kind of looks like a rectangular coordinate because I don't have any degree mark on that. But remember, I don't have a degree because it's in radians. So that's your polar coordinate of this rectangular coordinate. All right, now I want you to try one. Convert that rectangular coordinate into a polar coordinate and then come back to the video. All right, r is equal to the square root of this squared plus this squared, which is the square root of 20, or 4.47, and my theta is equal to the arctan of -4 over 2. Now this time my x is not negative, so I just leave it just like that. I don't have to add pi to it, which only happens when my x is negative, and that's going to give me a -1.11. So this compares to 4.47, -1.11 on the polar. So rectangular to polar. All right, the third thing we're going to talk about is equations. Up to this point, we've just talked about points, how to convert points back and forth. Now we're going to work with the equations, converting it back and forth. So we're going to start with polar to rectangular. All right, so let's say I have a polar that's r is equal to 6 times the cosine of theta. All right, well I know that if I square both sides, r squared is equal, well actually I'll multiply both sides by r, let's do that. So I have 6r times the cosine of theta. So I've multiplied both sides by r to give me an r squared. Well, r squared converts to x squared plus y squared, and then this part, you notice that this part right here is the same as my x. So that's given me my answer in rectangular coordinate language. So I went from polar to rectangular. All right, now let me show you from rectangular to polar. Let's say you start with this, x minus 3 squared plus y squared equals 9. I know what x is equal to. X is equal to r times the cosine of theta. So I substitute that in there, minus 3 squared. And I substitute in for the y. So I have r times the sine of theta squared equals 9. I hope I'm not going to go so far you can't see it. So I have r squared cosine squared theta minus 6, because I'm doing FOIL on this, r cosine of theta plus 9 plus r squared sine squared theta equals 9. Well, my 9 and my 9 go away. I'm going to subtract 9 from both sides. I'm going to put these two things together, and I'm going to factor out the r squared. So that leaves me with cosine squared theta plus sine squared theta. And then I have this part right here, the r that's not squared, I'm going to take to the other side. So 6r cosine theta. Notice I'm back with identities here. This is the Pythagorean identity, which is equal to 1. So I have r squared is equal to 6r cosine theta. I'm going to divide through both sides by r, and I'm going to get r is equal to 6 times the cosine of theta. This right here is my conversion from my rectangular to my polar. Now, if you were to think of this on a rectangular path, this would be a circle, and you know that that also graphs a circle, so it makes sense, or it should. Okay, now I want you to try a couple. r is equal to -3. I want you to change it from polar to rectangular and then come back. I'm going to square both sides, so I get r squared is equal to 9. R squared is the same as x squared plus y squared equals 9. This right here graphs a circle with a radius of 3, but this one, you know, also graphs a circle that goes out to the third circle. So you can see how those two graph the same thing. All right, now do the other way around from rectangular to polar. Try this. All right, so I've got that, and I've got to change my x and my y. So I have r times the cosine of theta squared plus r times the sine of theta minus 1 squared equals 1. I'm going to go ahead and square that, so it's r squared cosine squared theta plus, this is going to be FOIL, r squared sine squared theta minus 2 times r sine theta plus 1 equals 1, and I'm going to subtract the 1, and I can get rid of that if you will. I'm going to subtract the 1 from both sides. I'm going to move this part to the other side, and I'm going to factor out the r squared. So I have cosine squared theta plus sine squared theta equals 2 times r times the sine of theta. This is equal to 1. So I have r squared is equal to 2 times r times the sine of theta. I'm going to divide through by r. So r is going to give me 2 times the sine of theta. All right, so that's it. So let me give you your homework. Page 572, 14 through 39 all, and it's due Sunday at noon.